Imagine a situation in which a motor nerve that supplies one of your muscles is cut. Well, that muscle is then paralyzed. And unless we can get a signal to that muscle within the next year, that muscle is going to deteriorate and is never going to come back. What we can do is we can take part of a nerve and transfer it to that nerve that was cut, to the healthy end. That's called a fascicular transfer. You can see the architecture of the nerve. Each of those little bundles inside is a fascicle. So we could transfer to some of the fascicles, and what we can achieve is having one new function without ever sacrificing a different function. The other thing we could do is we could take an entire nerve, cut it, and move it over to power another nerve. So an example of this would be in the case where someone, let's say, has a brachial plexus injury and you couldn't move your shoulder. So we can take the spinal accessory nerve, which comes directly out of the skull, as opposed to the brachial plexus, which comes out of the neck. We can cut the spinal accessory nerve distally and de-innervate the lower part of your trapezius, and we could swing that nerve over, connect it to the suprascapular nerve, which innervates the shoulder muscles, and stabilize the shoulder instead. And that would be an example of a nerve transfer that would then give function.